All right, so here we're going to get into a calculus problem that's we're starting to get into what's called integral calculus, or as opposed to differential calculus, which is what the course is pretty much done up to this point, taking derivatives and all the things we can do with those. And now we're going to get into antiderivatives, or more commonly called integrals eventually, but we're kind of laying the foundation for that here. So this problem, estimate the area under the graph of f of x equals 1 over x from x equals 1 to x equals 5 using four right endpoint rectangles. And so I'm going to draw the graph of this, but you do not need to know what the graph looks like. You don't need the graph at all, but just to kind of give you an idea of what we're doing with this, I think it helps to see a picture in the beginning, um, just to kind of just until you kind of get your knowledge down and get a little more experience with this. So we're going from x equals 1 up to x equals 5. 1 over x, at least on this side of the y-axis, looks something like that. We'll kind of exaggerate a little bit. Um, and so we're wanting to estimate the area under the curve between 1 and 5. And this is just an estimate. It's not going to be exact. Um, we'll get to that later. We'll get to how we can make this exact later. But this idea kind of came from the fact that this is not a regular type shape. It's not a square or rectangle or a trapezoid or anything like that. We got a curved line here that makes up one side of this enclosed area. So we're using rectangles to approximate this. And so we're going from x equals 1 to x equals 5. So our delta x is going to be 5 minus 1. And then we're dividing this up into four rectangles. So we're going to divide that by 4. And so what this tells us is um, we're dividing this area from 1 to 5 in four slots. And so we can pretty easily do that by just looking at the rectangle that goes at each integer between there. And so what we're doing, let's draw that one, is we're going to estimate the area under this curve by finding the area of each of these four rectangles, adding them up, and then that will be reasonably close to what the exact area under this curve would be. Obviously, we're underestimating, so all these little areas right here are not going to be counted, but they should be. But we'll get a closer approximation until we get an exact. We can find an exact area eventually. But this just kind of get started with the idea. So now, how do you find the area of a rectangle? Obviously, the area is height, width times height. The width of each of these rectangles is going to be the same. And this will always be the case when we're doing these types of approximation. The width is always going to be 1, which is our delta x. So whatever your delta x is, that's going to be the width of each of your rectangles. Now, what is the height? The height of the rectangle is whatever the value is at these 4 points. That tells you the height of the rectangle. So f of 2, f of 3, f of 4, f of 5. So we'll just write f of x subscript I. And so that'll just be each of these. So, and we can even write this out to the side, f of 2, f of 3, f of 4, f of 5. But generally, mathematicians, we don't like to write out lists of things. We can write it shorthand. So f of x subscript I. So now the area is going to be the width times the height on this first rectangle. So that'd be 1 times f of 2 plus the width times the height on this second rectangle. So that'd be 1 times f of 3 plus the width times the height on the third rectangle, which would be 1 times f of 4, and then on the last one, 1 times f of 5. So obviously we have a one on each of these, and you'll always be able to do this, whatever the width is, and it's not always one. Um, it could be a half. It could, like if we divide this into 8 rectangles, the width would be a half. So we'd have to make twice as many rectangles, so the width would be half as much. Or if we only wanted to do two, which wouldn't be very good, but then the width would be, we go from 1 to 3 and then 3 to 5 would be our width. So that'd be a width of two. So it's not always one. It could be anything. Um, so remember this formula to find the width of the rectangles. But whatever the width is, we can factor it out because it's always the same for each of the rectangles. So really, we don't even need to factor it out, but we will. So 1 times f of 2 plus f of 3 plus f of 4 plus f of 5. And we'll drop the 1 since we don't need it. F of 2, so our f of x is 1 over x. So f of 2 would be 1/2. F of 3 would be 1/3. F of 4 would be 1/4. And then f of 5 would be 1/5. And then all we got to do is add those up. I'll let you do that in the calculator. I already did it, but we'll work it out. We get 77 over 60. And so that is our approximate area. The actual area under the curve is going to be a little bit more because we got that area we didn't count. We have that area we didn't count in that area and that area. So we're undercounting a little bit, but this gives us a decent approximation. And the other thing, if we wanted a more accurate area, we could divide it into more rectangles. And then these would eventually, these little areas that we're not counting, would get smaller and smaller and smaller. Another technique that is talked about in this section is the midpoint. So instead of using the right endpoint, we can use the midpoint. So use a rectangle there, and then we have a little bit that we're not counting there. We have a little bit that we are counting that we shouldn't be. So the midpoint gives a little bit more accurate. Still not going to be exact, but it's a little bit more accurate than the right. And you'll do some problems with those probably at some point. But that's the idea. So you want make sure you understand the idea here that we're trying to do. Don't just kind of memorize the way to do the problem, but understand what you're trying to do, how you're trying to do it, and then that will help you to kind of understand how we go forward from here. If you have any other problems that you would like me to do like this, you're welcome to leave that in the comments. If you have any other questions or anything else, drop a comment or send me an email if you got it.